Hey, Dr. J, 7.2, the second edition, second episode of the sum and difference formulas. Last time we learned sine and cosine. For both the sums and the differences. A very useful exercise to prevent you from having to look at your notes every 10 seconds when you're doing the homework or when you're working on anything in the future of this chapter would be to write these down from memory. So sine, that's actually the only one that I memorize. It's the easiest one to memorize. The sign stays the same. It's plus, plus. You do an alpha and a beta, and then an alpha and a beta. Yeah, so it stays in the same order. You just have to remember sine and then cosine, and then cosine and then sine. This formula is pretty forgivable if you accidentally did one of these in the wrong order because it's multiplication and addition. This is the one of all these formulas that will still give you the right answer even if it's out of order. Now, once you've memorized this one, watch how easy it is to get the next one. Just copy everything and change the plus to a minus. So there's your buy one, get one free for the day. For cosine, it's double cosines and then double sines. Let's write both of them down. And then remember, cosine is the weird one. If it's the difference, when you translate it into this formula, it becomes the sum. And if it's the sum, then it translates to become the difference. So those are the four formulas that we learned last time. Next, we're going to do tangent, alpha plus beta. Well, you already know from section 7.1 that tangent is the ratio of sine and cosine. So tangent of the sum should be the ratio of the sum, sine alpha plus beta over cosine alpha plus beta. All right, let's work down here. So we're going to have sine alpha cosine beta plus cosine alpha sine beta over cosine alpha cosine beta minus sine alpha sine beta. Now you could stop there if you want. This is the formula for the this is a formula for the tangent of the sum. So if you want, you could just use this version of it. I know I've done it before. If I can't remember the other version, I know that this version is always there. So this is the unsimplified version. It works. It's just messy. Okay. I'm going to try and clean it up a little bit by showing you a new trick. It's kind of an old trick revisited. For a long time in this course, many weeks and months, we've been using this trick where we multiply by 1. Okay, that's an old trick that keeps coming back. This time, I'm going to multiply by 1 in a very, very unique form. So this is a very special form of 1. It's a number over itself. Yeah, it's just a fraction, 1 over cosine alpha cosine beta, divided by 1 over cosine alpha cosine beta. So it's still a special form of 1. So now you're going to multiply these guys. So now you have sine alpha cosine beta over cosine alpha cosine beta plus cosine alpha sine beta over cosine alpha cosine beta all over, I'm running out of room here, cosine alpha cosine beta cosine alpha cosine beta, so those are going to match, minus sine alpha sine beta over cosine alpha cosine beta. That's hard to see, so I'm going to come up here and rewrite it for you. Top of the board here. So I have tan alpha plus beta is equal to, I'm just going to write the whole thing over again, sine alpha cosine beta over cosine alpha cosine beta plus cosine alpha sine beta over cosine alpha cosine beta. And then all of that, I'm just rewriting this messy thing down here. Cosine alpha cosine beta divided by cosine alpha cosine beta minus sine alpha sine beta over cosine alpha cosine beta. And you're going to see why this trick works now. It's kind of hard to see it. You know, how would you have known to do that? Well, I have to be honest with you. Nobody knows to do that until you've seen somebody do it. And then you go, oh, okay, that seems to make sense after you know it. The genius really lies in the first person that thought of it. And I have to admit it wasn't me. But this just works. It just works so nicely because this turns into 1. This turns into 1. Look at all the 1s you're going to get. So somebody, before we came along, unfortunately this last one doesn't have any 1s. You know, probably before many of us were even born, including myself, you know, they tried everything. They tried cosine alpha, cosine beta, sine alpha, sine beta, cosine sine cosine, and this is the one that happened to work. So all of these are 1, so you're going to get sine alpha cosine alpha plus sine beta cosine beta over 1. Yeah, so these are going to cancel essentially. They become 1. This is going to cancel, but don't forget you actually have to put the 1 here. Yeah, technically there's a 1 here and there's a 1 here, but obviously I'm not going to write these ones. And then you have sine alpha, cosine alpha, and then sine beta, cosine beta. And this is your finale. You have tangent alpha plus tangent beta over 1 minus tan alpha, tan beta. And there it is. That's your sum formula for the tangent of 2 angles, alpha and beta. I don't know. It's really a matter of opinion. Do you think this looks easier than the unsimplified version? The unsimplified version, if you remember, was sine alpha cosine beta plus cosine alpha sine beta over cosine alpha cosine beta minus sine alpha sine beta. I mean, I've had a pretty convincing argument that this is actually easier to leave it this way. But it's really up to you. So these 2 equations are equivalent. This is the one you would see in the book if you looked it up or if you Googled it. You know, what's the sum of the tangent? Okay. Similarly, I'm going to go ahead and skip the proof and just go ahead and give you the formula. If you've memorized the formula for tangent, you can get the other one very easily just by changing the sign. So watch how I do this. I copy everything down exactly the way it is here. And then I look. This is a minus, so up here it's a plus. This is a plus, so up here it's a minus. And there's your second BOGO for the day. So if you memorize the formula for tangent of alpha plus beta, you get the tangent of alpha minus beta for free. All right, let's do one. Our first example of the day. Our first catch of the day. Find the exact value of tangent, I don't know, how about 5 pi over 12? It's got to be something that we can use either a sum or a difference to get. Now, it really depends how long you've been doing this for. This is in radians. So I'm not sure if you think in terms of radians. When you get to your second or third semester of calculus, or maybe you were a wizard in your trigonometry class and you could immediately snap out what 5 pi over 12 is in your head. But maybe not. I know that most people on Earth are used to degrees. One of the reasons is 360. It's very close to a year, and that's not a coincidence. That's done intentionally. And so I think it's easier to think in terms of degrees, especially if you're a novice or a beginner. So you just multiply by 180 over pi, and this will immediately tell you what this is. It's 5/12 of 180. In other words, it's 5 times 15 degrees. I really don't need my calculator for that. 75 degrees. Now, maybe you already knew that. I don't know. Did you already know? I kind of knew, and I have a PhD in math. I kind of had the ballpark figure. I was thinking it's probably 75 degrees, but I like to do the math instead of just guessing what I think it is. So we want two numbers that add to be 75 degrees. So that's going to be 45 and 30. Pi over 4 is 45. Pi over 6 is 30. Those are ones that you should know if you passed a basic trigonometry class. These are ones that you should know. So this is my 45 degrees, and this is my 30 degrees. In my head, I've got 75 is 45 plus 30. All right, so we're going to use the formula. It's going to be tan 45, or pi over 4. Which one are we using? We're not using this one. We're using the sum formula. So we change this to a plus. And we change this to a minus. So you really only need one of the two tangent formulas, and you get the other one for free. They're all kind of like that. They come in pairs. All right, so we got our special triangles, pi over 4, 45 degrees, and your 30 degrees. Is 1, 2, root 3. Okay, so what are we looking for? We're looking for tangent. So Opposite over adjacent, or rise over run. It's just like slope. All right. So you have tan pi over 4, which is root 2 over root 2. That's just going to be 1. Yeah, here, I'll just put a little bubble. Root 2 over root 2, which is just 1. Tan pi over 6 is 1 over root 3. And then another tan pi over 4 is another 1. And then another tan pi over 6 is 1 over root 3. Simplify this as much as possible. It's not going to get much better, but you can do the following. You can multiply the numerator and the denominator by root 3. I'm not sure if you can see that. I mean, on your homework or on your test, if you type this in and it's correct, you know, I'm about 99% sure it'll mark it right. But it's a little bit of a beast to type. So you want to make your typing a little bit easier. You just multiply by 1, which is root 3 over root 3, and you get a much nicer answer. You get root 3 plus 1 over root 3 minus 1. Much easier to type into the computer than this previous version, but I'll accept either one. They're both correct. All right. Let's try another one. Example 2. Find the exact value. Cotan (95°). Sorry, not 95. 105. I was off by a factor, by 10. I'm trying to do mental math here while I'm talking. So, cotangent of 105°. Now this one I already have converted into degrees. If you prefer radians, I rarely ever have a student say they like radians better, but you could certainly do this. I might as well show you. I don't know how long it's been since you've done trig. You just put the 180 on the bottom and the pi on the top, and you get cancel off the degrees. You get 105 pi over 180. I think those are both divisible by 5 at least. So that's 21 pi over 36. Those are both divisible by 3. That'd be 7 pi over 12. If you prefer. If you prefer degrees, then do degrees. I'm actually going to keep working in degrees. So this is going to be cotangent of 150° minus 45°. That's how you get 105. Or you could do it in radians. Yeah, 45 would be pi over 4. 150 would be what? 5 pi over 6 or something? I'll leave that to you if that's your choice. Okay, you don't need a formula for cotangent. We don't have a formula for cotangent, so you're going to use the tangent formula. Then don't forget, I almost forgot last time, don't forget to flip your final answer. Reciprocal. Okay, so we're going to do tan of 150 minus 45. So that's going to be 1. And then I always forget the sign, so I just leave it blank for a second while I think. Tan 150, tan 45. I already got it wrong. It's tan 150, and then tan 45, then the 1, tan 150, tan 45. You may omit the degree symbols when it becomes clear. We're doing the subtraction. So the subtraction formula, the minus goes on top, and the plus goes on the bottom. You could just memorize that. See, whatever sign is inside the parentheses, that sign transfers over to the numerator of your expression. When I started writing it down, I accidentally wrote the bottom on top. So make sure. It will end up getting flipped, but I'm going to wait to flip until I'm done. If you want to flip it now, you certainly can. What I've done is I flipped it too early, and then I'll flip it again and end up getting it wrong. So, all right, so what is tan of 150? Tan of 150. So you've got 150 degrees. That puts you in quadrant 2 with a reference angle of 30 again. So again, you have root 3. You got 1 over root 3. But because we're in quadrant 2, the root 3 is going to be negative root 3 because the x value, you all know your x and y coordinates, the x value is negative when you're in quadrant 2. The y value is still positive. So that's going to be negative 1 over root 3. Or if you prefer, it looks nicer, 1 over negative root 3. That way it matches over here. Tan 45, we already know that. That's one you should have memorized. This is 1. And then 1 plus, and then you got another 1 over negative root 3. And then you got another 1. So that's going to be negative. I'm just going to pull this negative out to the front. And I'm going to pull this negative out to the front. And then I'm going to multiply top and bottom, numerator and denominator, by root 3. So now I've got negative 1 minus root 3 over root 3 minus 1. But this is tangent. Alpha and beta are here. Yeah. So alpha and there's beta. Okay, so therefore, cotangent of 105 degrees is the reciprocal of this. So it's going to be root 3 minus 1. Now, I could keep this as negative 1 minus root 3, but I like to write it this way. That way, it kind of has some sort of symmetry there. This is the final answer. I'm going to do one more annoying simplification because this drives me nuts. This just drives me nuts. So let me show you a trick here. If you want, you could stop now. I'm giving you permission all to stop now, but I just can't resist. I like to factor out the negative. Multiply or divide the top, same as multiplying, but divide that by a negative. So that becomes negative root 3 plus 1. And then I like to rewrite it 1 minus root 3 over 1 plus root 3. Super simplified. Or you could stop here. I don't care. These are equivalent. Just want to give you options. All right, well, not too much of this on there. I just wanted to get those formulas out so that we can move forward with them. The rest of these examples are applications in the very abstract sense of the word. We're not going to do any, true application problems, but what I mean are mathematical applications of the formulas for the sums and differences of all the different trig functions. So we'll go ahead and move on to that. One of the main uses of these formulas is to simplify an expression if you know something about it. So suppose you know the sine and the cosine of something. Suppose you know the sine of alpha is 0.441 and the cosine of beta is 0.748, and alpha and beta are angles with the terminal side in quadrant 1. I'm abbreviating quite a bit here. So suppose we know that we are in quadrant 1 and we have these angles, alpha and beta. We don't know what they are, and I'm not going to ask you today what they are, but I do know that I've got two angles, alpha and beta, and both of them lie in quadrant 1. And now I want to ask you, find the sine of alpha plus beta. What is the sine of alpha plus beta? So I've got to be really careful here. So I've got sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And notice I only know two of these things. I know sine alpha and I know cosine beta. However, I don't know cosine alpha and sine beta. Okay? So I need to be careful here. Remember, cosine squared plus sine squared is equal to 1. And I know what sine squared is. At least I know what sine is. In a minute, I'm going to know what sine squared is. So I can just take the given sine value and put it in here and solve it for the cosine, and that'll tell me what the cosine of alpha is. I definitely need my calculator today. So when you square 441 thousandths, you get 0.194481. And now you're going to subtract that from 1. I'm using my calculator. So 1 minus this decimal is 0.805519. And now here's the crucial step, okay? I need to take the square root of both sides. But there are two possibilities. So square root 0.805519, you're going to get 0.8975071103. Two possibilities depending on the quadrant. Since we are in quadrant 1, cosine of alpha in quadrant 1 is going to be plus in this case. All right, so we don't want the minus 1, we want the plus 1. So make sure you read it carefully. If it would have said it was in quadrant 2, then I would have taken the minus square root. If it would have said it was in quadrant 3, I would have taken the minus square root. If it said it was in quadrant 4 or quadrant 1, because we're talking about cosine, I would have taken the plus. Okay, similarly, oh, by the way, so now we know cosine alpha. Check, we got it right here. I'll probably round it in a minute. I guess I'll go to 4 decimal places. 0.8975. That's cosine alpha. Now I need sine beta. So I've got cosine squared beta plus sine squared beta equals 1. I know what cosine beta is. That's 0.748 squared. Sine squared beta. I'm going to solve this for sine. 0.748 squared is 0.559504. It's exactly the same steps. I'm running out of room very quickly. I'm going to do this on my calculator if you don't mind. So I'm going to subtract 0.559504. 59504. It's getting really messy. Sine squared beta is, I'm just going to do this on my calculator. And I get 0.440496. And now I'm going to take the square root. Again, the plus or minus depends on the quadrant. Okay, and again, since we're in quadrant 1, we're going to take the plus because we're in quadrant 1. So for sine, quick review, if you're in quadrant 1 or if you're in quadrant 2, then you take the plus. If you're down here in the bottom, quadrants 3 and 4, then you would take the minus. So it's very important that you pay attention to what quadrant you're in. All right, cool. So we got our sines and our cosines. I guess I'll round this to 4 decimal places. So we'll go 0.6637. All right, we did all of that work now. So now we've got sine alpha, cosine alpha is 0.6637. It's funny that the problem is given to 3 decimal places, but I'm asking for 4. Maybe that's because you can overestimate and then you can round back down to 4. To be really safe, you would keep all of these decimals until the very end and then do the rounding. I'll cross that bridge if it becomes a problem. If it's not a problem, I'm not going to make a big deal about it. All right, so these are our ingredients. We're We're not done yet. We're just getting started. Now we want to know what sine of alpha plus beta is, yeah? So that's sine alpha, cosine beta, plus cosine alpha, sine beta. You got all your ingredients, so just put them all in the pot and press start. So we got 0.441, 0.748, 0.6637, and 0.8975. It's all calculator work now. So let's do this one first. 0.441 times 0.748. I'm going to overshoot and then round down at the end. So I got more than 4 decimals, but I'll round it at the end. So I got 0.6637 times 0.8975. Overshoot it. So go more than what I'm asking for. Add these together and then round. .92553. The dictator is a 3. So you're going to get approximately 0.9255. All right, round to the nearest, what is that, 10,000th? Yeah, four decimal places. All right. Example 4. Same idea. Suppose sine alpha is 0.083 and cosine beta is negative 0.287. Both angles have a terminal side in quadrant 2. Find tangent of alpha minus beta. Remember that formula? It's tan alpha minus tan beta. Minus carries over, and the denominator becomes plus. Now the trouble with this problem, is we have sine and cosine, but we don't have tangent. Yeah, so we have missing tangents. And we're in quadrant 2, so we need to be a little bit more careful here. It's too bad that these aren't the same angle. Yeah, if these were both alphas or if these were both betas, we could just divide them and at least we'd have one of these, but we don't have either one. So this is a little bit of work. So before we use the formula, we need to find these first. Then proceed to the formula. Okay. All right, so what do we have? We have tan alpha is sine alpha over cosine alpha. I know sine alpha. I don't know cosine alpha. So I'm going to have to use that Pythagorean identity again. Sine squared plus cosine squared equals 1. I know sine. Okay. Squaring this. It's a very small number. It's 83 thousandths. So when you square that, you're going to get a very small number. 0.006889 plus cos squared equals 1. You're going to subtract. You know the story. It's the same story. The crow told me it's the only one he knows. So you're going to go 1 minus this. I don't even want to say it. 0.006889. That's 0.99311. And then you're going to take the square root. Now you have cosine of alpha is plus or minus the square root of 0.993111. Square root that. 99654. That's probably enough. 654. And this time, because we're in quadrant 2, this is a cosine. So this time we're keeping the negative. And I'm going to round to 4 decimal places. Now we're not even done. That's just to find the denominator down here. So now this comes over here. I tell you, you better be organized or you could easily lose track of this. And now you have your tan alpha. So tan alpha is negative 0.0833, rounding to 4 decimal places. All right, tan alpha, check, we got it. Okay, next we need tan beta. Whew, we need a bigger board. But I don't have a bigger board, so see if I can squeeze it in here. I'm going to erase this tangent formula for now because we're not going to use it yet anyway. I'm going to keep my quadrant 2 so I don't forget what I'm talking about and make sure I know that I'm going to keep that in mind. All right, what do we need? We need tan beta. So I got tan beta is sine beta over cosine beta. I have cosine beta. But I don't have sine beta. Okay. So I've got, so sine beta is what I'm looking for. So I got cosine squared beta plus sine squared beta equals 1. I know what cosine is. Cosine is negative 287 thousandths. I'm going to square that. You're going to get positive because you're squaring a negative. 0.82369. I'm going to keep all of that. I don't need parentheses anymore. Plus sine squared beta equals 1. I'm going to double check that. 0.287 negative, and then square it. Yeah, that's right. It's the same steps we just did. You're going to subtract. So you get sine squared beta equals, just do that on your calculator. So you're going to get 0.917631. Now you're going to take the square root of both sides. Oh, shoot. Oh, no. I lost that number. Got a little carried away with my erasing. Sine squared beta is that. So we're going to take the square root. Again, plus or minus. .9579. That's good enough. This time we're in quadrant 2. This is sine. So this time we're keeping the plus. Because it's in quadrant 2. Okay. All right. So now we've got our tan beta. It's going to be this 0.9579 divided by negative 0.287. 0.9579 divided by 0.287. Negative. So negative 3.3376. That's tan beta. I seem to have lost my tan alpha. You guys can rewind this. I unfortunately can't do that, so just give me a second here. I'm going to do a quick recall. So tan alpha got erased. That would be sine alpha over cosine alpha, 0.083. What was cosine alpha? So I got cos squared. Sorry, you're going to have to watch me do this one more time. I'll just do it quicker. Can't believe I erased that. Let's see. So I've got cos squared is equal to 1 minus 0.83 squared, or 0.83 squared. I'm just doing this quickly. You've already seen it. 0.083 squared. And then square root that. And we're in quadrant 2, so we took negative 0.9965. Oh, I remember that. And then that goes over here. So remember, tan alpha was sine alpha over cosine alpha right here. So that's negative 0.9965. So 0.083 divided by negative 0.9965. Oh, yeah, I remember that. It was negative 0.0833. That sound familiar? That's what I just erased a minute ago. All right, all of that work just to find tan alpha and tan beta. So now we want to find tan alpha minus beta. That was the original question. So that's going to be tan alpha minus tan beta over 1 plus the product tan alpha, tan beta. And these are all your ingredients here. You've got all 4 ingredients. Blank minus blank over 1 plus blank blank. Put everybody in the right spot. Oh, you only have 2 ingredients, actually. Tan alpha, tan beta. You don't need these anymore. Don't use sine and cosine. Unless you're using that other unsimplified version, you certainly can. So you got tan alpha, which is negative 0.0833. You got tan beta, negative 3.3376. You've got 1 plus tan alpha, so negative 0.0833, and tan beta, negative 3. It's the same numbers, 3.3376. And now it's just a calculator problem. So what do we got here? 3.3376. Notice these double negatives are going to turn into a positive. 0.833. So the numerator becomes 3.2543. That's the numerator. The denominator, again, you have double negatives. Those are going to turn into positive when you multiply them. And then you're going to add 1. So your denominator is 1.2770208. I'm going to keep it and then round it at the end. So 3.2543 divided by 1.2770208. You probably could have rounded sooner. I just wait till the end. So you get 2.5484. I'm rounding to 4 decimal places. Okay. An interesting observation about the answer. The answer is positive, even though we don't know what alpha and beta are. We don't know what they are, but we know that their angle must be in quadrant 1 now, because we started in quadrant 2 over here. We subtracted the angles and somehow ended up over here in quadrant 1. And we don't know the exact value of those angles, but we know that they are definitely less than 90 degrees now when you subtract them. Next, we're going to do the same process with fractions, because fractions turn out to be a little easier to work with. I rarely ever get a student that tells me they like fractions better than decimals, but there it is. Okay, example 5. Suppose sine alpha is negative 12/13. Alpha is in quadrant 3. And cosine beta is negative 8/17. Beta is in quadrant 2. Find the exact value of cosine alpha plus beta. So that's cosine alpha, cosine beta, minus sine alpha, sine beta. We know sine alpha, and we know cosine beta. So we've got that one and that one are done. We have 2 unknowns. We don't know cosine alpha. We don't know sine beta. So what do we do? Well, if these were decimals, we would take out our calculator and we do a whole bunch of calculations. But these are fractions. And they told us what quadrant they're in. So we're just going to do a little bit of geometry. So let's make one diagram for alpha and one diagram for beta. Alpha is in quadrant 3. and beta's in quadrant 2. Okay, so you've got cosine of beta over here. It's in quadrant 2. So negative 8 over 17. The hypotenuse is always positive. And then for alpha, you've got negative 12, and then the hypotenuse is 13. So if you see a negative in any of these fractions, for cosine and sine only, associate the negative with the numerator so that your hypotenuse is always positive. And now you can just do a little bit of geometry to figure out the missing side. You could use your calculator if you want, just because these numbers might get a little tough. So what do we have? Let's call this x, and let's call this one y. So we have x squared plus negative 12 squared equals 13 squared. You don't really need a calculator for this. 144, 12 squared, and 13 squared. So you're going to get x squared is 25. So x is plus or minus the square root of 25, plus or minus 5. Look at the picture. We're in quadrant 2, so x is negative 5. Sorry, we're in quadrant 3. The other one's quadrant 2. This is quadrant 3. All right, so for this one, we're in quadrant 2. We're looking for y, so we have negative 8 squared plus y squared equals 17 squared. I have to confess I've never memorized 17 squared. 289. I'll forget it in 5 minutes. 289 minus 64 is 225. So y is plus or minus the square root of 225. Plus or minus 15. Look what quadrant we're in. We're in quadrant 2. It's the y value, so we're going to keep the plus. So y is equal to 15. Throw out the minus. I'm not kidding when I say that you can spend a half an hour on a problem, and if you screw up which one's plus and which one's minus, you just lost a half an hour of your life, and you're not getting that half an hour back. It's gone. Okay. So cosine alpha. Okay, alpha's over here. Yeah. So that's going to be, let's go ahead and write it down. We've got sine alpha. We've got cosine beta. Let's go ahead and write down cosine alpha. That'll be negative 5 over 13, just using this triangle. And cosine, no, what do we want? Sine beta. For beta, we already have the cosine. We want the sine. That'll be 15 over 17. Wow, 8, 15, 17 is a perfect triangle, huh? 64 plus 225 is 289. Wow, interesting. No decimals. Everything comes out nice. Yeah. Maybe we should have done this first. Or maybe not. I don't know. All right, so what do we got? Cosine alpha. Cosine alpha, negative 5/13. Cosine beta. Cosine beta, negative 8/17. Sine alpha. Sine alpha, negative 12/13. And sine beta, 15/17. So that's going to be 40 over something. Negative, negative is positive. Whatever 12 times 15 is. Oh, we should know that's 180. The denominators are both the same. 13 times 17, 221. So the answer is 220 over 221. reduce this if possible, but it is very unlikely that it will be reducible. I've done 100 of these, and I'd be lucky if 1 or 2 was reducible. So, I mean, give it a try, but it's probably not reducible. So there you go. Okay, so that's pretty much it for the standard fare. We have to go to the deluxe version in a second here. Example 6. This one's a little tricky because we're given some strange values. So we're given cosecant of alpha is 8. Alpha is an acute angle, so it's less than pi over 2, greater than 0. And then we're given tangent of beta is -5. And beta is in quadrant 4. So this is these are the radian measures for the different quadrants. So from 0 to pi over 2, that's Q1. And from 3 pi over 2 to 2 pi, that's Q4. I like to give the quadrants in a variety of different ways. You can say the words, you can say the degrees, you can say the radians. There's lots of different ways to say it. So I'm giving you cosecant and tangent, okay? And I want 2 parts. I want to know what's sine of alpha minus beta and what's cosine of alpha plus beta. So 2 different parts. Unfortunately, we don't really have much. Yeah. We have cosecant and we have tangent. That's pretty much it. So what are we going to do? Well, I tell you what we're going to do. We're going to first take our cosecant and find sine. So that'll be 1 over cosecant. So that was easy. And it's an acute angle. It's in quadrant 1, so I don't have to worry about the pluses and the minuses. I know that that's going to be positive. All right. Now it's going to get a little tougher because in quadrant 4, oh, I should pause for a second. For what I just did, once you have sine, now you can find cosine pretty easily. You have your sine, so sine is 1/8. And here's your alpha. All you got to do is solve for x. Okay, I'll say DIY, do it yourself, or wait. I'll come back to it in a second. That's relatively simple. It's exactly what we just talked about. Yeah, so you're going to end up with the square root of 63. I'll say DIY, you could do that yourself. It's just solving the Pythagorean theorem using the hypotenuse of 8 and the opposite side of 1. Okay. I need to erase these really quickly, but I don't want to forget what they are. So A is sine alpha minus beta. And B is cosine alpha plus beta. That's just my reminders. You don't need those. You probably have them written down already. So I'm in quadrant 4. Yeah. That's my beta. And I know tangent. Yeah. Tangent is -5. But I don't know sine and cosine. Those are my unknown values. However, I do know that tangent is equal to sine over cosine. And I know that that's equal to -5. So I need to solve for sine and cosine. I'm going to need all this real estate here, so just really quickly, I'll write up here what I already have. I have sine alpha is 1/8, and cosine alpha is square root of 63/8. I might need those. I'm going to need those later in the problem, so I'm just going to remind you. And I'm also erasing this part here because I already know I'm over here in quadrant 4. So as long as I don't forget that, I'm good. All right, this is actually not as easy as it might look. Because there's a sine and a cosine, it's going to be tough. So what we're going to do is get rid of the cosine by writing it as the square root of 1 minus sine squared. Yeah, that's an identity that I can use to get rid of the cosine. Now, it's positive because we're in quadrant 4. Cosine is positive. Yeah, I'm on the right-hand side of the graph. Sine is actually going to come out to be negative, but the cosine will be positive. So now I have sine beta over the square root of 1 minus sine squared beta equals -5. I'm going to square both sides. That gives me sine squared beta over 1 minus sine squared beta equals 25. And now I'm going to solve this for sine beta. I'm never going to find beta, not in this section. Later in the chapter, we'll find beta. Right now, we're just finding what sine beta is. I'll never know what the actual angle is until later. So we're going to multiply both sides by 1 minus sine squared. So I get sine squared beta is 25 minus 25 sine squared beta. Then I'm going to add 25 sine squared beta to both sides. So I get 26 sine squared beta equals 25. Divide by 26. And then take the square root again. Don't forget your plus or minus. All right, now look where we are. We're in quadrant 4, and we're talking about sine. So it's going to be negative. You can't simplify the bottom. Just leave it as square root of 26. But you can go ahead and do the top. It'll be negative 5 over the square root of 26. So that's your sine beta. Whew. Now we got to remember that this is cosine, this denominator here. So we can go back and recover who the cosine was. All right, so we have cosine beta is the square root of 1 minus sine squared beta. I know what sine squared beta is. Sine squared beta is 25 over 26. Yeah, that's my sine squared beta, so that can go over here. 25 over 26. So that's the square root of 1 over 26, which is 1 over the square root of 26. Don't worry about simplifying the denominators. Just leave them as irrational numbers. All right, we're rolling now. So now we have sine of beta is negative 5 over the square root of 26. Cosine of beta, these are all our ingredients, is 1 over the square root of 26. I didn't show the step here. I was hoping that I didn't have to, but I hear a voice screaming at me through the internet. 1 is the same as 26/26. So that's how I got that so quickly without showing that. All right, well, remember half an hour ago, I put these guys off to the side here, and I said I would come back to them. So now we've returned. And now we can actually solve the problem. All of that stuff was just prep work. All right, so let's go ahead and do part A first. So we got sine alpha minus beta. It's all downhill from here. Sine alpha, cosine beta, minus cosine alpha, sine beta. You've got all your ingredients up here. Just pick them off your list. So sine alpha, that's 1/8. Cosine beta, 1 over square root 26. Cosine alpha, square root 63 over 8. And sine beta, negative 5 over square root 26. Simplify this a little bit, like get rid of the parentheses, double negatives. Do any kind of canceling that you can do. 63 is not perfect, but it's close. So you can leave it like this, 1 plus 5 square root 63 over 8 square root 26. That's okay. Or you can simplify the 63 is 9 times 7. The square root of 9 is 3, and 3 times 5 is 15. So if you prefer this, I don't particularly care. These are both correct. Either way. Unfortunately, there's not much you can do about the 26. Some professors would insist that you multiply by a special form of 1 to rationalize the denominator. I'm already coming up on over an hour here, so I'm going to have to stop. We're going to finish part B, and then I'm going to sign out. All right, so part B, really quickly. Cosine alpha plus beta. We already have all our ingredients, so let's just plug them in. Cosine alpha, cosine beta, minus sine alpha, sine beta. and just plug in all your ingredients. So radical 63 over 8, or you could simplify that if you want. I just wait. Cosine beta, 1 over square root 26. Sine alpha, 1/8. And sine beta, -5 over square root 26. So this is square root 63 minus, so that's going to be plus 5 over 8 square root 26. Or I would also accept 3 square root 7 plus 5 over 8 square root 26. Either one. Okay, 7.3 is almost done. It's a long section. Dr. Jordan signing out.